to True Projects. In this video, we are going to discuss about the project which is blockchain for the management of Internet of Things devices in the medical industry. So what are these Internet of Things devices, that is IoT devices? They refer to the interconnected medical devices that collect, monitor and transmit the patient health data in real time such as blood pressure and heart rate. So these devices they use secure communication channels and advanced cryptographic techniques to ensure data integrity and confidentiality. So to manage these IoT devices, it is very important, but they involve significant challenges. First challenge is the data security. Data security is crucial because these devices they handle sensitive patient information that need to be securely transmitted and stored to prevent unauthorized access. Second is data integrity. So, ensuring data integrity is vital since accurate and reliable patient data is essential for proper diagnosis and treatment, which means we need robust mechanisms to keep the data unchanged during the transmission and storage. Lastly, managing these devices efficiently is complex due to their large numbers and requiring regular updates. So, maintenance and monitoring to ensure they function correctly and securely. So, addressing these challenges is essential to fully benefit from IoT devices while protecting patient information and maintaining high quality care. Moving on, traditional methods for managing IoT devices and securing medical data, they typically rely on centralized systems that use standard encryption and authentication techniques. And these include centralized databases to store the data, conventionally encryption algorithms to protect the data during transmission and storage, and standard network security protocols to ensure secure communication between devices and systems. So these methods they provide structured approach to managing and safeguarding sensitive information generated by medical IoT devices. But these centralized systems they are prone to single point of failures because all the data and control are managed through a central authority or the server. So if server point is compromised or experiences a failure, the entire system can be disrupted, leading to potential cyber attacks and data breaches. Moreover, as the number of IoT devices grow, centralized systems struggle with the scalability and interoperability, which results in inefficiencies in managing large networks for devices and processing substantial volume of data. So this can cause delays, increase in the risk of errors, and reduce the overall effectiveness of the system in handling real-time data and device interactions. So to overcome these limitations, in this project, we integrate blockchain technology. So in this project, we are integrating blockchain technology. Specifically, we leverage Ethereum, which is simulated with the IoT devices in the medical industry to enhance the security, data integrity, and device management. So in this project, we'll be simulating IoT devices, and these they will be integrated with the blockchain, specifically Ethereum blockchain technology. So by utilizing blockchain decentralized ledger, we aim to eliminate the vulnerabilities associated with the centralized systems, such as single point of failures, which make them susceptible to cyber attacks and data breaches. So the decentralized nature of blockchain, it ensures that the data is distributed across multiple nodes, which makes it immutable and tamper-proof. Furthermore, the security framework, that is to strengthen the security framework, we also incorporated advanced cryptographic techniques such as epileptic curve cryptography, and the other one is zero knowledge proofs. So coming to this epileptic curve cryptography, it is employed to provide strong encryption for the data transmission, and it ensures that patient data is protected from the unauthorized access. And moving on to this ZKP, that is zero knowledge proofs, it allows for the verification of data without revealing the actual data itself, and it enhances the privacy and confidentiality. So by combining blockchain, that is Ethereum blockchain, cryptographic techniques, and the simulated IoT, we aim to create a robust and secure system for managing medical IoT devices and patient data. And this integration not only enhances the security and integrity of the data, but also improves the efficiency and reliability of the device management. So medical IoT devices, they can securely transmit encrypted health data to the blockchain where it is stored an immutable and transparent manner. So this ensures that healthcare providers can trust the accuracy and authenticity of the data, leading to better patient care and streamlined healthcare operations. So in this project, we used Ganache and MetaMask. Ganache, it offers a user-friendly interface that displays accounts, transactions, and smart contracts, which makes it easy to analyze blocks and access the data on our local blockchain. And those include file records, user information, system details, and interaction. Moving on to the MetaMask, on the other hand, it is an Ethereum wallet and also browser extension. And it allows users to manage cryptocurrencies, access the decentralized applications. So we use MetaMask for secure Ethereum transactions, which ensures the transparent ETH deductions and efficient handling to our cryptocurrency needs. Furthermore, to implement this project, we need software and hardware requirements. So coming to this software requirements, we need Python ideally of 3.7.0 version and Node.js, Visual Studio Community version, Ganache, MetaMask, which is the Chrome extension. And backend languages are Python, JavaScript, Solidity. And hardware requirements are processor of 5 and above, RAM of 8 GB and above, and ROM of 25 GB, 20 GB and above. So this is all about the project. Now let's execute it. To execute, we need to open the code folder which contains source code files. So these are the source code files in the code folder of the project. And in this contracts folder, we have files related to Solidity code. It handles data structures, functions, and events with the modifiers for validation. And these are the two Python code files. These will be executed during runtime of the application which supports the functionality. And this is the run.bat file. Instead of executing the project through command line interface, we have created this Windows bat file. We have to double click on it to execute the project. Before executing, we need to host the blockchain server. So I'm hosting the server. For that, open the Ganache. So server is hosted. Now get back to the code folder. Double click on run.bat file. This is the graphical user interface of the project, which is built using Tkinter framework. With this, we can interact with the project. So first, we have to generate the medical IoT sensors. For that, we need to click on this Generate Medical IoT Sensors button. Here we can observe that medical IoT sensors are generated, and here red color represents the medical IoT sensors and the blue color is the hospital which receives the information from this patient IoT sensors. So now we have to click on this Generate Private and Public Keys. We need to generate public and private keys because private key, it is the secret cryptographic key and it is used to sign transactions and the data, which ensures that the only key holder can authenticate or encrypt the data. So it is used to create digital signatures for the data collected from the medical IoT devices, and it ensures the data's authenticity and integrity. Coming to the public key, it is a cryptographic key derived from the private key, and it is used by others to verify signatures created with the corresponding private key. And it is shared with the blockchain's participants to verify that the data and transactions are legitimate and originate from the correct source, maintaining data integrity and the trust. So we will generate public and private keys. Here we can observe that private key and public keys are generated. Now we need to start simulation. That is, we have to send the information from patient sensor ID to the hospital. So we need to select the sensor ID first. So we will select as 9 and now click on start simulation. So here we can observe that from the patient 9, information is being sent to P11 node, and then the data is being sent to hospital, that is in the blue color. And here we can see the information related to the data transmission from the patient 9 to the hospital. And here is the sending packet which is being sent, that is from P9 BP85 heart rate 73 is being transmitted to the hospital. And here this is the ECC algorithm signature, and this is ZKP signature for the encrypted message, and this is the AES encrypted message. So this message has been encrypted like this. And this is the generated ECC sign for that encrypted message, and the verification is successful. And this is the ZKP's encrypted sign. And here ZKP's verification is also successful. And here is the decrypted message by the AES. Similarly, we will generate some more simulations. So we will select the 17 as the sensor ID. Now click on start simulation. Here we can observe that P17 is sending information to P2, and from P2, information is passed to the hospital. And here is the related transmission information. Let us do some more simulations. So I'm selecting 12 as the IoT sensor ID. Now click on Start Simulation. And here from the patient 12, data is transmitted to P2, and from there, here it is transmitted to the hospital. And here is the data transmission related details, which is sent securely. So now we will see the verification time chart. So click on that. Here on the x-axis, we have number of verifications, and on y-axis, we have the running time. Here, green color represents the ECC verification and ZKP represents the blue color represents the ZKP verification. So from both the verification techniques, we can observe that ZKP is taking less time to get verified. So it means that ZKP is performing well. Now close this. Now we will see the related data from the blockchain. So click on that. So here is the red data from the blockchain. So here we can observe that there are 4 patient IDs that we have simulated. Patient 8 we have generated. Patient 9 we have generated the simulation. Patient 17 and patient 12. And here are the related information to those patients. So here we can see blood pressure, heart rate, date and time when the data is transmitted. So similarly, we can transmit the data from the patient IDs to the hospital. So here we can observe that patient data is transmitted from the nodes to the hospital. So now let's see how the data has been stored in the blocks. For that, we have to open the Ganache and here click on blocks. So the data has been stored in all these 8 different blocks. So for each block, we have date and time, that is when that particular block is stored. So open the block 8, for example, and here we have block hash, transaction hash for the block 8. So click on transaction hash, and here we have sender address, to contract address, gas used, gas price, gas limit, and transaction data. Similarly, we will have for all of the blocks also. So using these blocks, we can retrieve the information. Minimize it. Now we will see how the ETH price is detected. For that, we need to open the MetaMask, which is the Chrome extension. So click on this MetaMask. And in the MetaMask, we can see I have balance of 99.998 ETH in my MetaMask wallet. And it represents the deducted amount after the recent transaction. So this, in the context of blockchain, transaction refers to the actions or the operations that are recorded on the blockchain ledger. Minimize it. So using this application, data from the medical IoT sensors will be transformed securely through encrypted manner using blockchain.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.